Okay, let's talk about displacement. So we're going to talk about this one, displacement. And displacement is a vector. So it's going to be a vector. We'll put the little hat here. And let's do an example. Let's say you have here your neighborhood, and these are the blocks. Okay, this is your neighborhood. Okay, and let's say you want to go from the post office right here. So you have the post office. This is the post office. Let's say you want to go from there, from this point, let's call it point A, post office, and let's say you want to go all the way over here to the store. So this is your store right here, your market store, and then you're going to go and you go this way. Okay. And here, let's say that from this point, from point A, let's say that you walk 2 miles. So you're going to walk 2 miles here. So this is going to be 2 miles. And then you go here and you turn and you go here and you make a 90-degree angle. And this length here is going to be a half of a mile. So then you get to the store. The store is over here. So you go from this point, from point A to point, let's call it point B, point A to point B. And let's see what is your displacement and what is the distance that you walked. So as you can see, this one in blue here. Okay, let me make it a little better. This one in the blue here would be the, let me make my blocks back here. So as you can see, you have this blue line here. That would be your displacement. So the blue line is your displacement. Okay. And how do we get that one? How do we get the displacement? Well, let's see. We have a formula. So the displacement is going to be equal to the, as you can see, you have a triangle here. You have a triangle that has an angle, and the angle is going to be this one right here. Let's call it theta. So the formula is going to be the adjacent to the square plus the opposite to the square, and then you get the square root of that. And that's how you're going to get the displacement. So your displacement is going to be this one right here. So it's going to be the square root of the adjacent, which is going to be your 2 miles. But you got to square this one right here, plus the opposite, which is 1/2 of a mile. But you got to square all that. So your displacement is going to be 4 miles to the square plus 1/4 miles to the square, and then you got to get the square root of all that. So your displacement is going to be equal to, if you add these two guys before you get the square root, that's going to be 16/4 miles to the square plus 1/4 miles to the square, and then you got to get the square root of all that. So your displacement is going to be 16/4 plus 1/4 is going to be 17/4 miles to the square, and then you got to get the square root of all that. So this is going to be the square root of 17 divided by 2 miles. And that would be your displacement right here. This is your displacement. And the distance traveled, which is not the same thing. So that is something else. So the distance traveled The distance traveled is going to be 2 miles plus 1.5 miles. So that would be 2.5 miles in total. And as you can see, they are not the same thing, because this is the distance traveled. This one right here is the distance traveled, and this one over here is the displacement. And these two guys are different quantities, so you can see it's not the same thing. And the displacement is the distance between A and B, and the distance traveled, the distance that you walk, would be 2 miles plus 1.5 miles. And what you get here is a vector. So this one right here is your displacement vector. And I'll put a little arrow here to stress out that this is a displacement vector. And we have found the magnitude of that displacement vector. The magnitude is the square root of 17 divided by 2 miles. Let's find the angle, so we can find what is the direction of the displacement vector, which is the displacement. So it's going to be this one right here. Let's see. So theta is going to be the arctangent of the opposite divided by the adjacent. So this is going to be your formula to find the direction of the displacement from point A to point B. So theta is going to be the arctangent of the opposite. The opposite is 1/2, and it's going to be miles, divided by the adjacent, which is 2 miles. So this miles cancels with miles. And this is going to be equal to the arctangent of 1/2 divided by 2 is going to be 1/4, because you put a 1 here, and then 2 times 2 is going to be 4. 1 times 1 is going to be 1 over here at the top, at the numerator. And this is going to throw you 14.04 degrees. And that would be the direction. So that would be the direction of your new vector. And there you go. You got your displacement vector, and you can refer it to a coordinate system. I'll just do that right here. So I'll do it right here. So what we have here is this is your x axis, this is your y axis. And you have your displacement vector. Okay, let me make it a little better here. And you have your displacement vector that goes this way. And your displacement vector has a magnitude of the square root of 17/2 miles. And has a direction theta, which is 14.04 degrees. And there you go. That's how you find the displacement. Displacement is a vector. So let me put here, well, this is the magnitude. What we're finding here is the magnitude of the vector. And when we find the angle, we find the direction of the vector. And there we go. And we'll do more of these. Thank you, and I'll see you in the next one.